All right, so homework questions. Yep. Which one?
So for like number 3.
Yep.
So for the first part of it, I did 2 times 2, which is 4, and then I subtracted 5 to it, and I got -1.
It was 2x,
Plus 5.
and that's 4 x's between.
-2 less than x plus or equal to 4.
So if you wanted to graph this, you didn't really have to graph it, just so you know. But I'll explain to you that in a minute. But I can answer your question here because this is, you will have to on the test. But for this question, you didn't have to. But if I'm making an x and a y chart, I'm plugging in -2 and 4 because I'm recognizing this is a line and all I need is 2 points. So one of the points would have a -2 as my x. That's the beginning point, and the other x I want to use is 4. So you're saying I have to plug it in, which is correct. So you go 2 times -2 plus 5. 2 times the -2 is -4. -4 plus 5 is a +1. That would be my output.
So in that case, I do 5 -2.
Whenever you plug in x, you do whatever. That's why, remember how we taught you order of operations? The reason we taught you order of operations first, before you ever do this kind of stuff, is because when you plug in x, now you have all known values down here. You're supposed to do order of operations.
So when do we skip that step?
Never skip it.
Okay. We don't just add 5 or subtract 5.
To the x?
Yes.
No, because there's a 2 in front of the x.
But when do you do that?
If there was nothing in front of the x, if you just had x
Okay.
plus 5, there's nothing in front to do.
So you just add it.
Right.
Okay, that makes sense.
Yeah. If I have a 3 here,
Yeah.
this really means 3 times x, then add 5. If I just have x plus 5, that just means take the x and add 5 to it. The difference is being there's nothing. There is a 1 here, but 1x is just x. Now you didn't have to graph that one because it says, Rebecca says there's an open circle at x equals 4 for both functions. Why is she wrong? Because what does it say right here? Or equal to, so what kind of circle would be at this location? A closed circle. She said it's open at both. Now, if we want to make Rebecca's statement correct, all we have to do is erase that, and now she's correct. There is an open circle at both pieces of that graph because it's not equal to on either piece. It means it can't be that. If I tell you x is greater than 5, it is a open circle at 5 and anything over here. Why? Because if I go to 5, is 5 greater than 5? No. But I can't just go, well, then why can't I just say it's from 6 on? Because there's all these numbers between 5 and 6. Because is 5.00000000001, is that greater than 5? But if I just started at 6, I would miss this number. There's an infinite amount of numbers between here and here. So that's why we have to go and we need to get as close as we can to 5. And so the way we show that is we go, hey, I got an open circle at 5, meaning it can't be 5, but everything after it is included. Whereas when I do x is greater than or equal to 5, now I go, oops. Now I go, this, here's 5, and now I'm telling the person, hey, it's 5 included and everything after it. Kind of makes sense? Real quick. Questions? Yes. On the one what? 2. Yep. Which one? Did we do 34? Okay. So 34, I'm not too worried about it. I don't want to spend too much time on it. First off, right here, what do I know it's going to be? What kind of equation? So like if I had A was y equals 3x plus 4, I had B, or even f of x, equals x squared minus 2, and C, f of x equals, I don't know, something, but with this involved, which one do I know it has to be? C. Why? Because I know this is a v, it has to be an absolute value, right? So what I mean by that is, we're going to start off by going, okay, I know this is an absolute value of x, something like that. Yes? And it goes over 1 and up 1, over 1 and up 1. Well, first off, remember my left and right movement? Where's my vertex? So there's no plus or minus here because there was no left or right movement. There's no plus or minus back here because there was no up or down movement. Now I'm going to try to figure out, was there a stretch vertically or a stretch horizontally? And when I look at this, it's 1, 1, 2, 2. That's just the OG. So f of x equals the absolute value of x should be my equation. Does someone mind? Do you understand what I mean by that? So that's A, part A. Yes, someone have a question online? Yep. If this person jogs to school, she travels at a rate of 2.5 blocks per minute. Write a function for this. So now all of a sudden she was doing 1 block per minute. Okay. So this is blocks. This is minutes. All right. Now so we said it was 1 block, 1 minute. Yes. Now she's doing 2.5 blocks. Now she's still 0, 0. Now she does 2.5 blocks per minute. Last time it was 1 block per minute. Do you get what I'm saying? Now the next one, she's going to be at 1, 2, 3, 4, 5. She would do 5 blocks in 2 minutes. And it would look like this. Well, did it move vertically? This is the OG, by the way, this one right here. Did this thing move up or down? No. Did it move up or down? Did it move left or right? How do you know? Where's the vertex still? So I know that it's still going to be f of x equaling some absolute value of x, and there's going to be nothing here and nothing here, because there was no movement vertically or horizontally. But do you notice it got skinnier? What is one of the ways that we can get something skinnier? By a stretch vertically. Well, if we went from 1 to 2.5, what if we put a 2.5 out here? Right? Put a 1 in for x. What's the absolute value of 1? What's 1 times 0.25 or 2.5? Isn't the output 1, 2.5? Well, you can put a 2 in for x. Absolute value of 2 is 2. What's 2 times 2.5? 5. Isn't that what we found to be here? Is that kind of making sense to you? And then it says graph it. I just did that. It all depends on the graph, right? So like, if I have something that's linear, I would know that it's y. One of the ways I can y it is y equals mx plus b. And in order to graph that, in order to have the equation, I need the slope and I need the y-intercept. Well, let's say this is -3, and let's say this is 4. Okay, well, one of the things I need is the y-intercept. That's right there. So literally in place of b, I would put a +4. I would leave the x because that's still there, but then I need a slope. Well, a rise over run is a slope, right? Wouldn't I go up 4 and to the right 3? Rise over run, 4, 3. So what would be my slope? 4/3. Y equals 4/3 x plus 4. So it all depends on the equation that you're given, right? So if it's a line, I'm going to do this. What we did about the, what we've talked about so far is when I have the absolute value, how do I fill that one in? Well, this part here, plus or minus, is if it moved left or right at all. This right here, plus or minus, is if it moved up or down at all. This right here is a vertical stretch. And I can fill all those pieces in by looking at the graph. Is that kind of making sense? And so that's what we're saying, like we should recognize what type of graph we have, and then that should help us go, like if I can go forwards, if I can give you the equation and you can get the graph, then if I give you the graph, you just work kind of backwards to get the equation because it's still all the same information, right? If I give you y equals 1/2 x plus 3, the way you would graph that is you would go 1, 2, 3, and then up 1 over 2, and then you draw your graph, right? Well, if I give you the graph, you would work backwards going, hey, I need this point because that's going to be the y-intercept. I have to go up 1 and over 2. I need that because that's the slope. And then you plot those things in. So it's just going back and forth between the two. And that's what we're going to do a lot this year. Okay? All right. Questions on homework? Yeah. Number 16. You guys didn't have a hard time on number 6? You guys got number 6 down? 1, 3. I'll do 16 because 16 is the same as 6. And then I'll do lesson, and if I have time, I'll come back to 6. But 16 looks like it's the same. Graph the piecewise function, state the domain, whether it's increasing. Actually, 16 encompasses everything we've done in all of chapters 1.1 to 1.3. So it's a great question. I don't know who picked that out. They're very smart. Oh, I did. 1.3. It's the last one that we did. Oh, there's a part that I didn't. Oh, okay. I hope this is one reason why that you're struggling. It's part of today's lesson, so this is good. This one right here is something that we're going to go over today. Okay. But you should have been able to graph this, and you should have been able to graph this. This one might have tripped you up a little bit, but I'll explain it to you. All right, first off, what's the lowest x can be for this equation? -2. What's the biggest that x can be for this whole equation? Nope, not 3. 7. Right there. Does that make sense? So that means when I do my x and y down here, well, this, I don't know why it keeps doing this to me. When I do my x, what do the values need to only be from? Say it louder. From -3 to, nope. From -3 to 7. Look, I said my x values are -2. Oh, did I say -3? Sorry. From -2 all the way to +7. That means on this, when I do my x and y, I'm actually going to shade a little bit here because I only have to go back to -2. 1, 2, 3, 4, 5, 6, 7, and 7 is as far as I'm going to get to going right. You understand how I got that? Now, I'm then going to recognize what type of graph is this? It's a line, so I only need how many points in order to graph it? So I'm going to use the 2 endpoints. What are my 2 endpoints going to be for this section of it? -2 and 0. So I'm going to plug those in. You're actually going to plug in -2, right? So it might be not very fun. Looks like this one's not very fun. Got some fraction work. By the way, told you in Algebra 2, you were taught how to deal with fractions in elementary school. That's because we have to deal with them. It's not a choice. So this right here turns into a +1/2. Negative times a negative is a positive. You end up with, the way you multiply fractions is you multiply top times top and bottom times bottom. So I end up with 2/4, which reduces to 1/2. 1/2 plus 3 is 3.5. I'm going to plug 0 in. 0 times 1/4 is 0 plus 3 is, so -2, 3.5. 1, 2, 3, 4, 3.5. Is it included or not? Is the -2 included or not? So at that point, what am I going to do? Open circle at -2, 3.5. And 0, included or not included? Not included. Oh, actually, it's supposed to be. It's supposed to be included, so I'm going to put a circle closed in and then connect the 2 dots. Now, actually, I hope that you could be able to do this one. We're going to explain it maybe a little bit better, but let's try the next one. Where's the next piece fall between? 0 and 4. It's actually also going to be a line. It's going to be a horizontal line, and we'll talk about that today, why. But what are my inputs going to be? 0 and not including 0, including 4. You understanding what I'm talking about? If I put a 0 in, is there a place for me to put a 0 in here? So what does that mean automatically kicks out? 2. It's just 2, right? There's no place. There, x doesn't affect what the output's going to be. Guess what happens when I plug a 4 in for x? There's no place to plug in a 4. So what kicks out still? A 2. We'll talk about that one a little more today. Closed circle or open circle on first one, closed circle on this one. So 0, 2, 0, 2, open circle. 4, 2, 1, 2, 3, 4, 2, closed circle, and it is a line connecting them. Is this helping you out? Oh, you are so lucky. Gigi. We're going to talk to Gigi. Congratulations, by the way, I didn't tell you that on Friday. And finally, what am I going to do for this piece? What are we going to, since it's a, what do I know it's going to be? It's going to be a line because x is to the first power again. So I'm just going to plug in. Nick, what's the first one I'm going to plug in? Nope, you're not even close to being with me, bud. You're zoning out. I need you with me. I don't care. I don't care what you have to do. You're not hurting my feelings. It is 4 that I'm going to plug in. What's the next one I'm going to plug in? 7. I know that from right here, Nick. Now, plug in 4. What is 3 minus 4? Try again. -1. What is 3 minus 7? -4. You with me? 3 minus 7. So then I get, it is not including the first one. It is including the second one. So 4, -1. 4, -1, open circle. 7, -4. Close circle. There's what that graph looked like. None of them connect. Now then it says identify the function whether the function is increasing or decreasing over the intervals. You with me? Colin, you with me? So from here to here, what would you say this graph is doing? Decreasing, right? What is it doing here? Your options are it's staying constant, and then what's it doing here? So what you would say is between, and since it's not including this number, right? So between -2, not including, all the way to 0, including. That talks about from here to here. You told me that thing is decreasing. Between 0, is it including 0? Nope. For the next one, I'm talking about from here to here, what's it doing? From 0, not including 0, because 0 was included up there. So from this one is not including, that's why it's an open circle, all the way to 4, including 4, it's staying constant. And then from 4, not including 4, all the way to 7, including 7, it's decreasing again. That would be how to describe the graph, whether it's increasing, decreasing over the intervals, and what intervals we're talking about.
So right to left is
From right to left, it changes. For a part of it, it decreases, right? Decrease, then it stays constant, then it decreases again. That's why we have to use these intervals, because it's not just decreasing. Like if I drew this line, what could you say about this? It's decreasing. Why? It's constantly, it stays decreasing the whole time. This graph doesn't. So you have to say between this piece and this piece, it's decreasing. Between this piece and this piece, it's staying constant. And between this piece and this piece, it's decreasing again. That's how you would write it with the intervals. Because this says starting at this x and going to this x from -2 to 0, it's decreasing. Yes. You got to just get that vocab down a little bit more. You'll get it. I got a review for you tonight that should help you out to tell you everything you need to know. Tonight you are. I got to do one of those part of the lesson. Here, I'll get the lesson out of the way and then you guys can ask me more questions. It's not, I kind of already did part of the lesson. F of x equals, first off, let's just go over this. If I say f at 1 equals 5, why is that better than just saying y equals 5? What does this tell you? Normally when we talk about x, we say it's an input, right? When I say y, it's just a what? So when I give you this, what information did I only give you? I only gave you the output. Y is this way better, and I can't write it for everyone, but I can write it for some. So if I asked you, what is the ordered pair for this one? You could say it was 1, that input, and then kicked out a 5. You could actually give me the ordered pair. Give me the ordered pair for this one. You can't. You have no idea about the input. There's no place that tells you what the x was that gave you that 5. So function notation is kind of cool because it gives you the input and the output. But we can't write function notation for everything because not everything is always a function. In fact, we'll go over one of the ones in class that you're supposed to do for homework and talk about why it's not a function. So, when you see f at 2, what is this signaling to you? That is your what? I can't hear you guys. That's your input. What do we call that? That's your x value. Okay? So when I tell you that, that's what you're getting for x. So if I say f at x, right now x is a variable, right? And then what I'm telling you is and Nick, you got to get it, bud. Got to get it together. So if I wanted, yeah, you should write this down. This is your notes. This is called a step function. It's still kind of a piecewise. It's part of a piecewise function, but we'll talk about why this is a step. All right. So what's the lowest x can be for this function? -3. What's the highest it can be? No. Did this to you on purpose.
4.
No. This says x has to be greater than 2. Does it ever stop? No. So it has a minimum for the x, but it doesn't have a maximum for the x because it keeps on going forever to infinity. Because x just has to be greater than 2, which means anything greater than 2. So 3, 4, 5, 6, 10 billion, right? It would keep on going. I'll show you what that's going to look like then. So what did we say it started at? -3? Then I'm just going to have some here. But I'll show you what happens at the end. All right. So what happens is when x is between -3 and 0, if I want to graph the first piece, what's the first number going to plug in? -3, right? But what happens when I go to plug in x? There's nothing to plug into, correct? So what does f at -3 equal? Well, -3 falls in this category, right? And then I write everything that's on the side of this. So f at -3 equals, and when I go to write this, it just tells me that it equals what? 2. What happens at 0? 2. Now remember, since it's not equal to, what am I going to put there? Open circle. What am I going to put at this one? So -3. I hate technology right now. -3, +2. I'm going to put a closed circle all the way to, it was 0 to, right? But with a open circle. Now the next one picks up where? Nope. Okay, where's the next one pick up as far as my x coordinate? 0, good. And where does it go all the way to? Nope. No. It picks up at 0, and where does it go to?
Infinity.
2.
Oh, never mind.
Now, when I plug in a 0 in for x, what is my output? 3. Good. When I plug a 2 in, what is my output? And since it's both equal to, what kind of circles am I going to put on both of those? So closed circle here. And 2. And finally, the last piece of this thing, which you can just leave your X and Y's. You don't have to keep erasing it. I only have a certain amount of room to work on, so I got to keep erasing it. If I put a 2 in, what kicks out? What if I put a 3 in, what's going to kick out? What if I put a 5 in? What if I put anything bigger than 2, what's going to kick out? So for this one, and it is an open circle for the first one, does that make sense? So I'm going to put 2, 4. Oh my. I'm going to throw something. So 2, 4, I'm going to put an open circle, but then I'm going to draw this line and it's just going to continue on forever. So I'm going to put the arrow because it doesn't have an ending point on this one. Because it's, yeah, as long as it keeps, because there's no, it's not like it's between two numbers. Like right here, I'm telling you, hey, the X is between 0 and 2. So between 0 and 2. This just says it has to be bigger than 2. So that means anything here and forever over. It would have been anything numbers less than this. Yep. If it was said greater than or equal to, then I would have closed that circle in. It wouldn't change anything about this. It would just change whether it's a closed circle or open circle. Now, is this a function? Does every input only have one output? Yes. This one looks like it has 2 output, but what does the open circle signify? It's not that one. That's not where I'd go. I'd go here for my output. If I asked you, what is F at 0? What is the answer to that question from here? What is F at 0? Would I plug it into the top one? No, not. Why not? Because 0 is not less than 0. It's equal to, and this one doesn't say it can be equal to. So you would not plug 0 into that one. You'd plug 0 into this one. So what's F at 0 equal to? Now, when we're making the graph, we have to plug the 0 in just to show us where it would be going, because that's where all the other ones before 0 would be going to. And that's how we show it getting as close as we can. But then we throw that open circle on there saying it's not allowed to be. Does that make sense? Right here. Because now how many times, and that what would happen here is it would be equal to here and equal to here. So I would have to plug the 0 into the top one and in the bottom one, which would give me 2 different outputs for the same input. We're going to talk about that in just a second for one of the ones, but yes, that's what it would look like. And you would have 2 closed circles right on top of each other. Okay, so like the homework question, it was a great homework question, number 15. It says in the relationship, it asks, is this a function or is it not a function? And so they gave it to us as y equals. The reason they gave it to us as y equals is because if they say that, it can be a function, but it doesn't necessarily have to be. If they say f at x equals, then it has to be a function. So when they leave it kind of like this, it's kind of like maybe it is a function, maybe it's not. And they're asking you to decide whether this is a function or not. So let's look at this. This says for any time x is less than 2, I'm going to use this equation. So if I look at that on my number line, anytime x is less than, but not equal to 2, so that means anytime it's here, no, I don't want a crayon. Anytime it's here, my graph is going to fall somewhere over here. Does that make sense? It could be up or down, I don't really know, but it's going to be anytime it's less than 2, I know there's going to be a piece there, okay? But this one says, hey, there's going to be a piece of this graph whenever, I think that's supposed to be -2, whenever x is greater than -2. which means there's going to be a piece. So this one's the yellow one. This is the yellow part that's going to be graphed. And this one we're going to make the green. And it's saying anytime x is this, then there's going to be a green part. What's the problem? There's a part where there's going to be two parts of the graph, meaning like if I said, hey, I want you to figure out f. What if I said x is, oh my gosh, that's the smallest eraser ever. What if I said I want your x to equal 0? Well, is 0 less than 2? Is 0 less than 2? So if it makes it true, you have to plug the 0 in for this x. So 0 times 7 is 0. 0 minus 4 is -4, right? So there's 1. But then I check again and I go, wait, is 0 greater than -2? It is. So I would also have to plug the 0 in for this x, and I would get 0, 5 out. What's the problem? I have the same input, but I have different outputs. What does that mean this is not? It is not a function, because I have one input that has multiple outputs. Why did it have multiple outputs? Because there was a part of the graph that both of them are going to be overlapping. There's going to be maybe this one's a line like this, and maybe this one's a line like that. And this overlap is going to be where I'm going to have one input with two different outputs. Now, how could we change that? Come on, stay with me. I know I got 3 minutes. I can get a lot done in 3 minutes. How could I change this? Because it said this right here. How could I change this so there is no overlap, aka so it becomes a function? Well, instead of making the x less than -2, what if I made it greater than -2? And for this one, what if I made it less than -2? There would be no overlap, so there would be a piece of the graph here, there would be a piece of the graph here, and then every input would have its own output, making it a function. What? No, I do the coloring just to help it make sense for you guys. Does it make sense or no? Questions? Questions? Yes. No. I was just saying, how could we, let's change, what if we wanted to make this equation a function? If we had changed those things, now they would be all opposite directions. There would be no overlap, and now this equation would be a function. So it's like an extension.
But in general, don't.
No. That's the problem. Then I would have to do it exactly the way it's written. I'm saying, okay, it's not a function. What could we have done to this problem to make it a function? Or what could they have done, the book have written, and it would be a function? It's just me adding on. That's not something you would do. But I mean, they do, this book does ask questions like that. They'll say, if it's not a function, then rewrite it so it would be. And that's what I was doing. I was rewriting the equation so that it would become a function. I don't know who this one is. Did you guys get my joke today, though? Why did the student get upset when the teacher called them average? Because that's just mean. The average is a mean. Come on. All right, that's it. Online, appreciate it. Any questions? There will be a recording of this online.